We're going to look at the electrolysis of aqueous solutions. And once we've briefly looked at one aqueous solution which we have performed electrolysis on, I'm going to ask you to plan an investigation for the electrolysis of another type of aqueous solution. So I'm very briefly going to give you an outline of what happens in the electrolysis of sodium chloride in an aqueous solution known as brine, and we're going to break down that reaction, and then you are going to plan an investigation for the electrolysis of another type of aqueous solution by doing some of your own research. When sodium chloride is dissolved in water, we get brine. We call it brine. So brine is essentially dissolved sodium chloride. And we've dissolved sodium chloride in water. So this is brine. However, this is very concentrated sodium chloride. And this brine is very important in industrial processes. When we perform electrolysis on brine, we are going to get 3 products. And these 3 products are very useful because they are used to make other chemicals. So the 3 products that are formed from the electrolysis of brine is 1, we've got chlorine gas. Okay, and this chlorine gas is produced at the anode. So chlorine gas produced at the anode. Okay, and you should know by now the anode is a positive electrode. Then we have hydrogen gas being produced at the cathode. Okay, and cathode is the negative electrode. Then we have sodium hydroxide solution, which is formed and left in the container. Solution formed, and this does not form at the anode or the cathode, it is just forming in the container, and we're going to see why in a bit. So can you just take this down? This is brine. Brine is sodium chloride dissolved in water, and the products of performing electrolysis on brine are 3. We have got chlorine gas, hydrogen gas, and sodium hydroxide solution. So let's make it clear at the top. Products of electrolysis on brine, okay, are going to give us the 3 below products. You have the word equation for the electrolysis of brine, and I want you to take the word equation down. Sodium chloride under electrolysis so under electrolysis will give us hydrogen gas, chlorine gas, and sodium hydroxide solution. Now, I want you to give me a complete balanced equation for this reaction. And what I'm going to ask you to do is to balance the equation that I give you. So I'm going to give you a partial equation and I want you to balance it. So here are the products and reactants. Okay, so I've given you a partial equation here. I want you to complete this equation by balancing it and completing anything else onto the equation that makes it fully balanced and complete. So balance it by putting in the correct coefficient and then looking at anything else that is incomplete on the equation. So just pause the video here and can you attempt to balance this equation? Okay, so let's balance this. We should have a 2 here, 2H2O, 2Na, 2OH, and in terms of coefficient, this should make it balanced. Now, this equation is still not complete yet. We have to include state symbols. So the sodium chloride is in an aqueous state. This is water, so we put this as liquid. The sodium ions are in an aqueous state. The OH minus ions are in an aqueous state. The hydrogen gas is in a gaseous state and chlorine is in a gaseous state. Here you can see what is happening in the electrolysis cell for the various products that we have obtained. You can see where the hydrogen ions are migrating towards and you can see where the chlorine ions are migrating. And also you should note what's happening to the sodium and the hydroxide ions. They're not migrating towards, well, they're not interacting with the electrodes to produce any product. So could you just take this diagram down for the electrolysis of brine under this equation, under the equation that you've taken down. So just pause the video here and take this diagram down to reflect what is happening in the electrolysis cell. And once you've done that, we're going to move on to talking about what is actually happening at the anode and what is happening at the cathode in terms of oxidation and reduction. So we're just going to put a few points down for the reaction at the anode. So we'll just bullet point what's going on. Negative chlorine ions, negative chloride ions, are attracted to the anode. Okay, so this was stated before when we were talking about the three products. Now, when they get to the anode, they will each lose. So each chlorine ion, each chloride ion will lose a single electron. So each ion, each Cl minus ion will lose one electron. Okay, so each Cl minus ion will lose, each chloride ion will lose a single electron when it reaches the anode. The chloride ion is oxidized. Okay, because they've lost electrons. Remember the word oil rig. Oil is oxidation is loss of electrons. So the chloride ion is oxidized as they have lost electrons. Now when they lose electrons, they become atoms. Now the chlorine atoms now bond together because to form a diatomic molecule, so they bond together in pairs and chlorine gas is produced. So chlorine atoms, and notice the difference between the word atoms and ions where I'm using it. The chlorine atoms bond together to form Cl2 molecule, and this is a gas as well. This is in a gaseous state. Chlorine Cl2 in a diatomic state exists as a gas. So this is just a statement about what's happening at the anode. Now let's put in the ionic half equation for chlorine at the anode. So what happens is we say the ionic half equation. So we half equation is 2Cl minus aqueous. Remember our state symbols. Let's make that a bit clearer. Two Cl minus aqueous goes to Cl2, so chlorine gas, plus 2E minus. So this is our ionic half equation for what's happening at the anode when there's electrolysis of aqueous sodium chloride. This is the ionic equation, half equation at the anode. Can you take it down and make sure that you clearly mark the ionic half equation and identify it? So hydrogen ions, H plus ions, and sodium ions are going to be attracted to the cathode, but as hydrogen is less reactive than sodium, it gets discharged while sodium stays behind in the solution. Now we have to look at the half equation at the cathode. So the half equation at the cathode, we get so for the half equation we're going to get 2H plus aqueous plus 2E minus gives us hydrogen gas. Now I want you to tell me on Teams whether the hydrogen has been oxidized or reduced. So can you type back on Teams whether the hydrogen has been oxidized or reduced? So I'll repeat again. Pause the video here. This reaction at the cathode, which is occurring, has the hydrogen been oxidized or reduced? Use this ionic half equation to help you to answer that question. Now, moving on, the hydrogen atoms which are migrating towards the cathode eventually bond together. their atoms bond together and a gas is given off. So just as chlorine gas was given off at the anode, here hydrogen gas is given off. So once the ions have gained their electrons, according to the equation, they've gained their electrons, but I'm not going to tell you if it's oxidation or reduction, you have to tell me that. But the hydrogen ions are gaining their electrons and they are becoming atoms. And what happens is the hydrogen atoms bond together to form H2 gas. The question may be asked, where are the H plus ions coming from for the hydrogen to be discharged at the cathode? It comes about when the water is ionized or broken down, and this is a reversible reaction. So I've put the reversible reaction here, which happens when the water is broken down and we get our H plus and OH minus ions. So could you just take this reversible reaction equation down, and this is where the H plus ions are coming from. Now it may be asked further, why doesn't the sodium get discharged instead of the hydrogen? Why are we discharging hydrogen and not sodium? Because sodium is also positive, it should be attracted to the cathode and is attracted to the cathode. However, only the hydrogen is discharged. This is because, to understand this, we need to look back at the reactivity series to understand what's going on. Here we can see that hydrogen is lower in the reactivity series than sodium. And as a rule of thumb, the lesser reactive element of the two ions that are migrating towards the cathode will get discharged. So if we take sodium and hydrogen, hydrogen is less reactive than sodium. Therefore, it gets discharged first. So hydrogen will form H2 gas at the cathode and leave in a gaseous state. Sodium is left behind and forms its sodium hydroxide solution in the electrolysis cell. So as a rule of thumb, it is the less reactive element that gets discharged. Can you take that down? Because this will help you predict the products of electrolysis for aqueous solutions. If you're given more than one type of ion in the solution and you have to decide which one is going to be discharged based on the two migrating towards the same electrode, you have to refer to the reactivity series. To help you with determining what products will be formed at the cathode or the anode, I've given you here the dissolved substance, the formula, and then the product at the cathode and the product at the anode. So here you've got a list of seven different types of dissolved substances, aqueous substances, which you can use to look at what products are being formed at each electrode. Now, generally, you should get into the habit, once you're confident in this, to predicting it without doing it by memorization, to understand based on the reactivity series. But for now, can you take down these aqueous solutions and their corresponding cathode product and anode product? Now I want you to complete this task here. So can you complete these 4 questions, and can you upload your answer back onto Teams for me to check through? So can you work through these 4 questions, and can you write in full sentences and upload your answer back onto Teams?